use them every day, even if you never actually see them. They're in your phone, your car, your laptop, even your microwave. They're called semiconductors. And they're the invisible force behind almost everything in the modern world. Chips made from semiconductors run our devices, connect our networks, and power the tools behind artificial intelligence, defense systems, and national economies. And today on Brain Snacks, we're diving into what they are, how they work, and why the entire world is racing to control them. Let's start with the basics. A semiconductor is a material, usually silicon, that can sometimes conduct electricity and sometimes not. That on-again, off-again behavior makes it incredibly useful, because when you use it to build tiny switches called transistors, and you pack billions of those onto a wafer the size of a fingernail, you get something powerful. A chip. That chip becomes the brain of your smartphone, the controller in your car, the storage in your computer, the processor in a drone, the heart of an AI model. Everything digital runs on chips. And those chips come in a few main flavors. The ones people talk about the most are called logic chips. These are the brains. They process instructions and run software. Apple's A-series chips, Intel's CPUs, those are logic chips. Next, you've got memory chips. They store your stuff. Apps, documents, videos, entire operating systems. Samsung and Micron are big names here. Then there are AI chips, the kind of chips that have made NVIDIA a household name lately. These are built to run artificial intelligence, especially machine learning. They do one thing really well: math. Lots of it really fast. And finally, there are microcontrollers and analog chips, the behind-the-scenes workhorses. They open your garage door, keep your fridge cold, and control the temperature in your coffee maker. They're everywhere, just quietly doing their job. Now let's rewind for a second, because chips didn't always exist. Before semiconductors, electronics ran on vacuum tubes. They were huge, fragile, and got hot fast. In 1947, scientists at Bell Labs invented the transistor, and everything changed. By the 1970s, we had microprocessors. Intel made the first one. Computers got smaller, then faster, then cheaper, then everywhere. And with each generation, the number of transistors on a chip kept doubling, a pattern known as Moore's Law. That exponential curve powered the digital age. But building a chip? That's no small feat. It takes a supply chain so complex, it makes your iPhone look simple. It all starts with design. Companies like NVIDIA, Apple, AMD, and Qualcomm create the blueprint. What should the chip do? How powerful should it be? How much energy should it use? To turn that idea into reality, you need software, EDA tools, made by firms like Synopsys and Cadence. These help engineers turn concepts into instructions for machines. Then come the machines themselves. The most complex is an EUV lithography system, basically a laser printer for atoms. These are built by one company, ASML in the Netherlands. Without them, the most advanced chips wouldn't exist. Once you've got the design and the tools, you need a place to build the chip, what's called a fabrication plant, or fab. This is where companies like TSMC in Taiwan and Samsung in South Korea come in. They're the best in the world at physically building the chips, with precision measured in nanometers. Finally, the finished chips are cut, tested, and packaged in countries like Malaysia, Vietnam, and the Philippines, before being shipped off to power your phone, your car, your laptop, or your toaster. That's the supply chain, a global relay race that spans dozens of countries and thousands of steps. And if one piece breaks, everything slows down. So who are the giants running this world? At the center is TSMC, the Taiwan Semiconductor Manufacturing Company. They don't design chips, they just build them. But they build for everyone. Apple, Nvidia, AMD, and they make over 90% of the world's most advanced chips. Then there's Intel, the original chip titan. They used to lead in both design and manufacturing, but in recent years they've struggled to keep up with TSMC's pace of innovation. Meanwhile, Nvidia has taken the world by storm. They design chips that power AI, chips like the H100 and Blackwell, and they've built a software platform around them that developers depend on. They don't own fabs, but they dominate the AI race. And don't forget Samsung. They lead in memory chips, the ones that store your data, and they're also a key player in logic chip manufacturing. Now here's where things get tense, because chips aren't just a tech story, they're a geopolitics story. Taiwan is at the center of global chip making, which means that any conflict over Taiwan, especially with China, could ripple across the entire world economy. The US has responded by tightening restrictions. It's blocked advanced chip exports to China and banned the sale of certain chip-making tools. China, in turn, is pouring money into building its own domestic chip industry. Chips have become national security assets, right up there with oil and rare earth minerals. That's why, in 2022, the U.S. passed the CHIPS and Science Act, a $52 billion effort to bring more chip manufacturing back to American soil. The idea is simple: reshore production, reduce dependence, and stay competitive in the global tech race. Factories are already under construction in Arizona, Texas, Ohio, and New York, led by Intel, TSMC, Samsung, and Micron. But even with all that momentum, this industry still faces massive challenges. First, it's expensive. A single chip fab can cost $20 billion or more, and take 5 to 7 years to build. Second, the supply chain is fragile. One earthquake, one shipping delay, one geopolitical standoff, and production can grind to a halt. Third, there's a major talent gap. We need more engineers, physicists, technicians, and fast. And finally, there's physics. We're approaching the limits of how small we can make transistors. Moore's law is slowing. The old playbook doesn't work forever. So where do we go from here? The future of chips isn't just about making them smaller, it's about making them smarter. AI chips are getting more efficient. Edge computing is moving processing out of data centers and into everyday devices. Quantum chips could one day solve problems regular computers can't touch. Neuromorphic chips are being built to think more like brains than calculators. And as data centers continue to consume more power, there's a growing push to design chips that use less energy and create less heat. The race is on, not just to make faster chips, but to build a better future with them. So the next time your phone unlocks, or your car avoids a crash, or your AI assistant responds in perfect rhythm, just remember, it all started with a tiny switch, etched with the lasers, built with atoms, and made from sand. That's all for this episode. Thanks for tuning into Brain Snacks. Subscribe for more big ideas, explained simply.